Welcome, everybody. Hello, good morning, or good afternoon, good evening, depending on where you're located in the world. And welcome to our session. This is the fourth AskTOM office hours session for graph technologies. We'll focus today on how to visualize graphs. If you're new to this series, my name is Jean Im. I'm a product manager for Oracle Spatial and Graph products. And today, our key presenters are, as always, my good colleagues and experts, Albert Godfriend, our Spatial and Graph Solutions architect based in Nice, France today. You may see Albert all over Europe and the Middle East, actually, because he works closely with customers and partners in this region and delivers many talks and workshops on spatial and graph technologies. So actually, if you're in that area and interested, keep an eye out for Albert. He'll be coming through with a great roadshow and hopefully be at a conference near you if you'd like to meet him in person. And our other expert is Gabriela Montiel Moreno, or Gaby. She's our software development manager for Property Graph Technologies, and she's based in Guadalajara at Mexico's Development Center. And this is Gaby's first appearance on the AskTOM series, but in addition to her development work and her development management work, she's also delivered a number of talks and workshops at both academic and industry conferences. So we're really delighted to have Gaby on with us today. So before we jump into the content, a few housekeeping notes. Everybody's lines are muted, so please use the chat to enter any questions, and we do highly encourage you to ask questions, as the main goal of office hours is to give you tutorials, but also give you a chance to share your problems or issues and interact directly with our product team's experts. One proviso, though, we cannot discuss any bug reports, any SRs, or licensing issues on this series. And then just be aware, if you do post things like code into the chat, the other participants can see that unless you direct your message specifically to the hosts of the session. So as mentioned, today is our fourth session that we've had, and we're focusing basically on the specific topics that you need to go from zero to being a fluent user to apply property graph technologies to solve some of your business problems. Our previous sessions are all recorded and available. If you've missed any of them, go to the AskTOM landing page at the URL that you see at the top of the page, and you'll find all the recordings. So past topics included an introduction to property graphs, learning how to model graphs from relational data. Our last session dove into the world of performing graph analytics and getting an insight into some of the powerful capabilities that they have to reveal insights on relationships latent in your big data. And now today we get to the fun part, which is visualizing graphs. And both Albert and Gaby will show you how visualization is a very easy, intuitive way that will reveal even more powerful insights into your data. Again, that landing page is always available for recordings and for you to enter in questions that you'd like answered on future sessions, feedback, and such. So we welcome your input there. Thanks, Albert. Next slide, please. So just to recap the story so far, for just a very brief recap of our last sessions. Again, check out the video recordings if you did miss any of those. Oracle does offer two software products supporting graph data management technologies. On the left, we have Big Data Spatial and Graph to manage graphs in a big data environment, such as Hadoop, NoSQL, or HBase. And on the right, Oracle Spatial and Graph is the set of technologies for graphs in relational databases. Both of these products are available both on-prem and in the cloud. Our AskTOM series focuses largely on database technologies, but many of these property graph features are also available on big data platforms as well. Next slide, please. here is the architecture of our property graph database data management support. Starting from the bottom up, we provide highly scalable, secure storage of property graph data, and you have a choice of using either a relational database, 12.2, Oracle 18.1, or big data stores like HBase or NoSQL database for that data storage. And in the database, we can leverage technologies like parallelism to achieve very high performance. In blue, in the middle, we have a common data access layer, or DAL. This is a Java layer that allows application developers to query, fetch, and filter graph data from the database through Java, JDBC, SQL, etc. We expose Blueprint's APIs and provide tight integration with text engines like Lucene and Solar Cloud as well. On top, to analyze the data, we have an in-memory graph analytics engine called PGX, which can read graph data from the storage very efficiently through DAL. And this is where we provide the 50 or so analytical functions out of the box, and take a look at the last session for more detail on those algorithms. On the far right-hand side, to visualize the data, we offer a number of options, including open source tools, or there are partner technologies, and that's the focus of today's session. We have on the right a number of different interfaces for developers to interact with graphs as well, including Java and Python wrappers. Next slide, please. A refresher on what is a graph. It's a data model that represents entities as vertices and relationships as edges, and it can optionally include attributes there. And the real power here is that unlike some relational schemas, graph can be a lot more flexible. You don't have to predefine a schema. You can easily extend it. It's very well suited to sparse data. And again, the real power is the range of new types of analytics that it enables that relational technologies either can't or find very cumbersome to achieve. Next slide. And graph analysis can yield business insights, such as identifying influencers in a social network, or discovering patterns in big data, finding patterns of fraudulent behavior in financial transaction data, for example, or generating recommendations for a retail product recommender engine based on what similar customers are buying. And we're seeing graphs more and more in industries like in banking, finance, public sector, intelligence, retail, and even manufacturing. So let's dive into it. Today, Albert will show you why you'd want to visualize graphs and how you can do it. Then Gaby will show a demo of some cool graph visualizations using Cytoscape. So take it away, Albert.
Thank you, Jean. So as you just said, why would we want to visualize graphs in the first place? You know, here is on the left side is a simple graph. And analytics, that's what we've been discussing in the previous session, allow us to identify important vertices, like important customers, the ones which are heavily connected, very influential customers, or relationships like patterns in common fraud, etc. And that is maybe all we need. Maybe we want to just invite these important, influential customers at our next conference. But still, it's nice to see things. And so a visual graph like the one we see here highlights the results. For example, in the Panama Papers case, we don't really need a graph. We can just list the people we suspect of fraud. But having a graph that shows how businesses are connected to each other, how bank accounts, money transfers, financial flows, makes things so much more interesting. And so that's what we want to do. Now, as an example, I'm using this graph, and I'm pretty sure everyone knows the people that are in this graph, the names. They are the characters of the Game of Thrones, HBO, and books as well. And so they show us, what do they show? They show the relationship between these people. Now, these relationships are actually what were shown on the previous slide as a tabular format. Here they are shown as a graph. But they show us more than a graph, because they show us also things like, for example, the size of vertices of the circles. Big circles indicate influential people, so the characters which appear a lot, which have a lot of impact on the plot, like it says here. The size of the names also indicates their connectivity. How are they related to each other? Are they serving in interconnected multi-communities? And then the color indicates communities. Now, these have been computed through graph analytics, like pagerank to find out the important ones, centrality to find out to derive the label size, and community detection to detect the communities. Could I show the results without the graph? Yes, of course. I could just have a tabular result that shows Tyrion, Rob, John, Daenerys in that order, because they are the more important, and then also indicating lists of names that are in the same community. But showing it visually is nice, because it gives us much more information. And by the way, if anybody is interested in looking at this, I indicate a URL here where you can go and find out about, actually can download the file with that example graph, and also what results have been found at. And consider this one. You see, this is the same graph. It's the same data, same characters, but here they are not symbolized. All I have is circles of the same color, lines of the same color, and they are not really spread around. I can't really figure out what's happening here. I can only figure that out if I do a proper visualization. So how do I do that? Well, there are libraries available, open source libraries. Some of, like these ones here, are pretty well known. D3.js, Viz.js. They can do all kinds of fancy visualizations, including graphs. And the graphs that we see here also are dynamic, meaning that using your mouse, you can move them around, turn them, change the layout, and essentially place them in different ways to highlight different things. You can configure things like the color of the vertices to reflect maybe some attribute. Maybe blue are people and green are bank accounts, etc. On the right side and side as well, you can use symbols for doing that. There are commercial tools. Tom Sawyer Perspective. Tom Sawyer software is a pretty good, loyal partner to Oracle. Their main offering is called Tom Sawyer Perspective. It's fully integrated with Oracle, so you can use that to view graphs, to interact with the graphs, to issue analytics. Available on desktop, so thick client and web installations. Another one is Linkurious. Linkurious is a French company. They also specialize in graphs, they specialize in analytics, but they also have a full Oracle integration that allows you to use that in your applications and build applications that do this visualization. And then there's Cytoscape. Today we're going to talk mostly about Cytoscape. So why Cytoscape? Well, Cytoscape is open source. It's originally from biological research, hence the name Cytoscape. Cyto means a cell, like cell. And over time, it has developed into a general platform for complex graph analytics and visualization. So any graphs, any sort of data. It is desktop, pure Java, so runs anywhere on your Mac, on your Windows PC or Unix, Linux. It's extensible via plugins, and that's very interesting, because what we have done is actually developed a plugin that will extend the abilities of Cytoscape so that it can actually connect to our graph stores, whether it's big data or database, and that allows you to perform analytics, so to, for example, do a PageRank computation, a community detection, or even generate PGQL. There's also a JavaScript library called Cytoscape.js, which can also be used in your application development. So like I said, Cytoscape allows us to, well, with the property graph plugin, allows you to run pretty much all the analytics that we provide. So like here, specify component and visually see the results. Installing Cytoscape is easy. You just download it from cytoscape.org. It comes with macOS installer, Windows installer, Linux installers. There's also a platform neutral installer, just like a zip file you unzip and run. And the plugins we distribute on over our OTN platform. So you need to be registered and check in and sign on to actually download. And you see we have two versions of the property graph. There's one for the spatial and graph platform, and one for the big data spatial and graph. The only difference really between the two is that one of them allows you to read graphs to connect to a database. The other one allows you to connect to a big data platform, so essentially Edge-based or NoSQL. There's some configuration you need to do, or you can do, like setting up a database connection, username, name of graphs, and some configuration also on the server side, the PGX or the PGX server that runs the analytics. And then once you start, you need to connect to a database. Now, at that point, you specify database connection, but here we have a problem in a way because we don't really want to show the entire graph. For small graphs like the Game of Thrones graph, that's okay. It's like 100 nodes or 200 nodes. It fits on the screen. It's actually visible. But for large graphs, like the Panama Papers graph, or a financial fraud detection graph where we have like possibly hundreds of millions of transactions, it's just not possible. And so therefore, we provide a way for you to choose a starting point. Where do we start with the graph? Like, for example, start with the most important vertices, you have PageRank or centrality, start from random vertices, or start for specific vertices. And then so you get that graph, and then you can expand the graph. You can start from one particular vertex, get the edges and the connected vertices, and so explore the graph and gradually bring more of the data on the screen. This is pretty much the way all graph visualizations work. So graph manipulation means we will, or the Cytoscape plugin will then call our data access layer, fetch the graph, retrieve the schema information, find out how are these graphs, what are the properties, what's the name of the graph, etc. And then essentially build a temporary graph which can then be visualized. And visualizing is viewing the graph, but not just viewing the graph, it's also deciding on which layout is most appropriate for the graph, what information we can find out, about the graph, and also configure the graph so as to have, let's say, different colors or different shapes for the node, depending on what they are, and same for the edges. You can search in the graph, so find out those edges or vertices which have properties with certain values, like here, only select those edges where the country property has the name as a value United States. And you can set up visual mapping rules. So you can decide how things should be rendered to make them more intelligible, understandable, like different colors depending on properties, etc. An example of finding a shortest path between two vertices will give us that result in highlighted in pink here. Right? Then PGQL. We've not talked too much about PGQL. In fact, our upcoming session of a month from now, we'll go over PGQL. PGQL is like SQL for graph. It's property graph query language. It's being normalized as an ISO standard. It lets you do queries which look like SQL, so select blah, 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 from the implied graph, so there's no from clause here because there's only one graph anyway, and then the where clause, and the where clause you see there with the parentheses and square brackets is a graph expression. It says essentially, well, we don't see everything, but here it probably says something like, give me all the edges, all the vertices in our graph, that so that they admire another person. So choose a property to see it. That also is very powerful. That lets us do graph pattern matching, find cycles in graphs, find who knows who knows who knows who, so multi-level hierarchies. So the PGQL query is sent to the in-memory analytics execution engine, who then performs the query and then returns the result as a graph, which then is visualizable. Now, when we do this analytics, that is interesting, of course, but we want to save the results. That's possible. So we can save the results of an analytics, so the graph that we obtained from running some operator, PGQL or PageRank or whatever, save them as a graph in database, and then reload them as a graph later on, and then we use them again for more analytics as subgraphs. We can also import the graph data file. That's, of course, something we will do with the APIs, but this lets us do it this way by just filling in, specifying the files to load. And this could be the GML, GraphZone, GraphML, that should be. So GML, GraphZone, GraphML are well-known file structures. GraphZone is JSON for graphs. GraphML is XML for graph, and GML is just another structure. There can also be the Oracle flat file format, the OP, OPV files, which are mostly used for transporting graphs from one system to another. And editing graph is possible, so adding new vertices, and as well as adding edges. And of course, deleting vertices and deleting edges. Deleting vertices will then automatically trigger the deletion of the edges that connect to these vertices. All right, so that's the way things are working. Now, I'm going to pass over to Gaby. Gaby is going to take over, and she's going to show us a demonstration of doing all these operations using Cytoscape. So Gaby, you can take over now.
So what we are going to show now, it's an example using some demo data from banking accounts. And what we are going to show you is some of the capabilities that you can use with Cytoscape. So what we want to cover here is how you easily can present data. So as or Albert showed you before, is what you can do is basically start based on how well you know your data. So that means that if you don't know your data, you can start by choosing a set of random nodes so that you can figure it out how your graph data looks around. So this is a starting point that we are going to show first. So as Albert previously mentioned, you can simply connect to Cytoscape, the ones that you have configured, and install the Cytoscape plugin. In this case, we are going to show it using Oracle Big Data Spatial and Graph, but the interface and the functionalities provided for both Oracle Data Spatial and Graph and Oracle Spatial and Graph are pretty much similar, and the look and feel is similar. So when you access Cytoscape, what you have to do is basically log in and specify where you want to load the data from. In this case, we are choosing to load the data from Apache HBase. We just need to specify the connection data. And as I mentioned before, which is the starting point. In this case, we are just going to use some random nodes. So in Cytoscape, you can also specify how you are going to label your vertices so that it's easier for you to identify what are your vertices about. So in this case, we can show to you use a name as a label. So we can also start again to load a graph, but now using a different starting point. For example, if we know a set of vertices, vertices IDs that we want to start with. And we can again show the label that we want to use, which is again the name. There are cases when we know that some of the vertices may have this property, but some of them doesn't have this property, as we may have properties from different kind of entities. So a different way that we can start, it's based on a key value search. So for example, let's say that we can start by looking for all the entities or like banking accounts or customers that belong to a specific country. In this case, you can start by loading a graph, specifying a key value search, detailing which is the property that we want to look for, and a text search pattern. In this case, we are looking for an exact word, which is all the countries from China. We also can specify if we want to display only a subset of these results, because it may be the case that we found a lot of matches for this key value search that we just execute. We can again modify how we are going to label our vertices when we are visualizing them, but we can also start from a different starting point. In this case, we can execute a page ranking. The page ranking, as Albert already mentioned it's allow us to identify which are the vertices that have most influences in the graph, which means which are the vertices that are most connected, like have the most number of incoming or outgoing edges. So when we start from a graph and execute the top ranked, what we are going to see is the most influential vertices. We can again show the label so that we can get an idea of which are the vertices in the graph that have most influences. and then we can move on with the visualization on the graph. So then to visualize which are another starting point, we can also start with a PGQL. In a PGQL, as Albert already mentioned, it's basically some kind of SQL for graphs. So what you can specify here is some kind of graph query pattern over your graph data so that you can identify all the vertices and edges that are satisfying this kind of query patterns. So in this case, what we are looking is for all the vertices that are either clients or bank accounts, and we want to identify relationships between these entities. It's important that when we start from a PGQL and we specify this PGQL, as this PGQL query involves properties like the type and the name, we need to specify them and the set of vertex properties as well as the edge properties. So when we get execution of the PGQL, there are two ways that we can visualize the results. One is in a tabular result and also as a subgraph. So from this subgraph, we can start visualizing the data. We can explore which are the banks and how they are related with another entities like clients and accounts, and which are the type of relationships that they have with each other. And we can also do different operations like expansion and so on. Another feature that we have enhanced from Cytoscape in order to work with property graph is the creation of visual mapping rules. The visual mapping rules, the main objective is to make it easier for the users to identify the different kinds of entities that are in the graph. So if you have vertices that are of different type of, you want to identify vertices with different conditions, you can specify visual mapping rules so that you can set a coloring or shapes to each one of these different type of vertices. For example, we can set a pink color to all the entities that we know that are banks and that they belong to HSBC accounts. Or we can specify different colors for the different vertex types, like a bank account, or a bank or accounts or customers. Also, we can do visual mapping rules for edges. For example, if we want to identify the transfers that have an amount bigger than $50K, then we can set a different color and a different shape. Also, if these transfers are done in a different currency, like yens of dollars, we can also use a different mapping rule. So this makes it easier for the customers to visualize which are the relationships and the relationship types that are belonging to the graph. So here you can see how the graph, you can identify how you can have different entities and each one can be displayed in different shapes. And using Cytoscape, you can also select a graph and display the different attributes and properties that each one of these entities have. As I mentioned before, for example, we specified a specific shape for all the transfers that have a currency of yen. So as Albert already mentioned, we can also use PGX to execute different algorithms and graph analytics over the graph using Cytoscape. So we can execute analytics like finding the most influencer entities in the graph using top ranking algorithms provided by PGX. So in an existing graph, we can run this algorithm, and these top ranked vertices are going to be highlighted. And we can also use it to identify communities. So we can run either WCC algorithm that is provided by PGX or label propagation algorithm. So from the existing graph, we can run it and we can identify the different clusters. So in this case, from the existing graph that we have, we can identify that there are 10 clusters found. And the user can easily navigate and identify the different type of clusters detected by the algorithm. Another way to identify community detections is using a PXWCC algorithm, similar to what we do here. We can use the WCC algorithm. In this case, we are going to identify a different number of clusters. And the user can navigate again and analyze which are the entities involved in each one of the graphs, the clusters that this algorithm generated. Another way to identify community detection is by grouping vertices based on a specific properties. So we provide in Cytoscape the capability to execute this detection of communities. So the user just needs to click on the group by property. Just select the property that he or she wants to use as a community detection. In this case, what we are going to use is type, and then just generate the communities. In this case, what we are going to see is only 3 main clusters, because we have 3 main entities, which is basically the clients, the customers, and the accounts, and the banks. From there, the users can continue visualizing or evaluating which are the main entities that are involved in each one of the clusters by simply just selecting on each one of the entities and then expanding the vertex so that you can see all the adjacent vertices to this one of the clusters. So going back, as I mentioned before, Cytoscape provides a set of functionalities so that you can execute PGQL queries directly from Cytoscape and visualize the results as graphs. So we provide a set of plugins so that you can directly execute your SQL PGQL query. You just simply need to specify the query. It's important that when you specify your PGQL query, and it involves a set of vertex properties and edge properties, that this set of properties are defined in these boxes so that they are taken into account when the query is executed. And we also provide a capability so that you can load a PGQL from a file or export this PGQL into a file. Because it may be cases when you want to execute a PGQL from time to time, so that you don't have to retype it again and again. In this case, what we were looking for is basically all the outgoing edges from a specific client. So again, we can use the show label capability of Cytoscape so that we can set the type and we can easily check which are the entities involved in the relationships found by the PGQL query. We can also use our visual mapping rules so that we can get a better idea on how these relationships are about. And then we can later on move on and explore more the graph. We could do more expansions on the vertices, or we can try different queries or graph analytics and so on. In this case, we are going to try with a different query. So what we are going to do is going to back to look for all the relationships coming from either a bank or a client. So again, we can show the results as a tabular results, but also as a subgraph. Similar to what we did before, we can set a label so that it's easier for us to visualize the results as well as mapping rules, so that we can identify which kind of relationships we have and if that these are transfers and if which are the currency of the transfers that we are dealing with between the bank accounts and the clients. So now we can also look for a specific account. So for example, we can search for all the transactions that are coming from a specific bank, which is BBA Bancomer, and searching for all the interactions with clients. So if we also show the label from type, we can check all the clients that are related, and we can check that all the transfers accounts, transfers relations that are being done to them. So how about dealing with big graphs? So we have tried Cytoscape, and we have tried visualizing bigger graphs, like dealing with thousands of vertices and edges. So in this case, we simulated again data from bank accounts and customers from thousands of vertices and edges, so you can easily visualize it. What you can do also is to bundle the edges. You can define how you want to bundle or collapse the edges, so it's easier for you to visualize what the data you have. You have different layouts so that you can work with your data. One of them is a circular layout. Another, it's the one provided by Cytoscape, that it's the link long layout. And similar to what we did with a small graph, you can also apply into a bigger graph top-ranked algorithm so that you can identify which are the top influencers on this graph. So in this case, what we want to do is find the 10 higher influencers in the graph. We can highlight these top-ranked vertices. We can show the properties of these vertices so that you can get an idea of what these vertices are. And also another capability that we have in Cytoscape is to provide a functionality to find a shortest path between two nodes. So the user can either specify the source and the target, and you can visualize as a graph the shortest path between these two entities. This graph that it's big enough, it's a little tricky to identify the the starting and the end point of the graph, but you can see the path. So if we move back to the same functionalities that we show you in a smaller graph, you can do the same using a bigger graph. So you can execute label propagation so that you can find the communities in the big graph, where you can identify these 100 more clusters. And each one of these clusters is identified by different shape and different coloring. You can run another algorithm like WCC algorithm. In this case, you will find that only one cluster is found. And you can also combine it using a bundle of edges so that you can get a different look for the graph. And this is like a general overview of some of the main features that we have for Cytoscape. So, Albert, I bring the control back to you.
I need to.
Yeah, and while we're switching over slides, just a reminder, we do have some time, so feel free if you have any questions to type those in the chat.
Can you see that?
Yeah, that looks good. Thanks, Albert. And thanks to Gaby for that great demo, and Albert for the overview of the power of visualization with this graph data. So I think those examples really showed how got a lot of dense business data, whether it be banking transactions, and graphs can really reveal what's going on and give new insights that will really add some value, answer the kind of questions that banks or other businesses are looking at. So yeah, for folks, we did compile a list of some helpful resources, whether you're just getting started with graphs or whether you're an advanced user and want to dig into some more detailed technical information. So we've got product websites at the OTN site that have a range of white papers, downloads, and more videos for your consumption. We have 2 blogs that focus both on property graph as well as our geospatial technologies, and members of our development team regularly update those with cool tips, tricks, answers to the most frequently asked questions from users. And we've highlighted one blog entry from our partner, Arthur Dayton, he's done a great tutorial on how to get started, and he specifically focuses on the Oracle database platform. Just again, you have some relational data. What do you need to do to get it into a property graph format? Our YouTube channel has many other videos on both beginner and advanced types of graph topics. So check that out when you have a chance. For those who want to get your feet wet and kind of play with graph technologies in a big data environment, we have the Oracle Big Data Lite virtual machine. That's a free sandbox environment you can download quickly. There's hands-on labs with graph technologies, and that's a nice way to get your feet wet as well. So Albert, next slide. Great, thanks. And this is a pointer to some tutorials that our Oracle Labs, who actually developed the PGX in-memory analytics engine, have also posted for folks' use. And this particularly can give tutorials on many aspects of using graphs with an emphasis on some of the algorithms that are available. We are pretty active on social media, so feel free to follow myself, Albert, our product management colleague, Hans, on our Twitter handles. And we also have active spatial special interest user groups who have both a LinkedIn and a Google Plus online community that's open to anybody who wants to join, and they typically have updates with the latest news, events, as well as pointers to articles and technical tips of interest to the community. So that's really a great way to get involved and see what other users are up to. Oracle OpenWorld is coming soon. It's October 21st through 25th in San Francisco. Most of you are probably familiar with this, our largest flagship conference of the year. Wanted to call your attention that this year the Java 1 conference has actually turned into Oracle Code 1. It'll include all of the Java developer content that fans are come back for every year, but it also includes a wide range of extended developer content on the whole range of other Oracle technologies, including a lot of database-related content. So I think that'll be an even better, bigger conference with something for everybody this year. And we're pleased that we're planning a number of technical sessions, overview sessions, demos, hands-on types of sessions around graph technologies. And the listing here is a sample of some of those scheduled sessions thus far. So if you can make it out to San Francisco, come join us there. Check it out. Our other main event that's geared towards the community for analytics users, machine learning, big data, database. It's an event that takes place every spring called the Analytics and Data Summit, held at the Oracle headquarters in Redwood Shores. And we usually have a full track of both spatial and graph sessions there. The date has been scheduled for spring of 2019 in mid-March. So save the date for that. There's a URL if you want to stay up to date on updates there. And again, we do have about 10 minutes left on today's session. So if you have any remaining questions that come to mind, again, feel free to enter those into the chat. After this session is done, the AskTOM landing page, again here that I pointed out at the beginning of the session, is always there and available for you to access the recordings. We'll be uploading the recording from today's session pretty soon as well. You can also submit any kind of feedback or questions and sign up to be subscribed for updates on upcoming AskTOM graph sessions here. As Albert mentioned, our next session in October will deep dive into the PGQL query language. It's a very intuitive yet powerful language to execute property graph related queries. So I hope you'll join us for that. So yeah, I think that brings us to the end of our content here, and the chat has been quieter than usual today. So I think maybe Albert and Gaby have explained things so clearly that people have no confusion, which is a good thing, I think. So Albert and Gaby, do you have any closing remarks or tips? And here's the last call to you guys to ask your specific questions of the experts.
See you again in about a month's time when we talk about PGQL. We showed a few examples of that. Gaby showed some cases where PGQL was used. PGQL, like I said, is a SQL-like language. So if you know SQL, it's pretty easy to learn PGQL.
Great. Another way for database users to quickly get spun up on making graphs a part of their data management and everyday language. Okay, awesome. So I guess we've gotten some nice feedback here, but yeah, you guys did a great job. So with that, I think we'll say goodbye for now and see you in October. And thanks everybody for joining today.